buckle up because today we're diving into some seriously cool AI research.
Really cool.
That's right, we're talking about making those already super smart language models even smarter.
Yeah, like pushing the boundaries of what AI can do.
Exactly. And more importantly, we're going to be looking at how to make these models think more like we do.
Which is a good thing, right? I mean, we don't want AI just spitting out answers. We want to know how it got there.
Exactly. Like if an AI is going to tell me what stocks to buy or, I don't know, give me relationship advice.
Hopefully it's not giving you relationship advice.
Well, hypothetically, I want to know, it's not just pulling stuff out of thin air, right? I want the reasoning, the logic.
Absolutely. And that's what's so fascinating about these two research papers we're diving into today.
Right. One from OpenAI, the other from Stanford.
Both tackling this whole thinking before speaking challenge, but from totally different angles.
Love it when researchers come at a problem from different directions.
Me too. Makes it way more interesting.
Okay, so first up, OpenAI's paper. Let's verify step by step.
Catchy title.
Right? Straight to the point.
Exactly. And the paper itself is pretty straightforward too, at least the idea.
Reaches.
Instead of just looking at the AI's final answer, they're saying, hey, let's break down its thought process. Let's see how it's actually getting to that answer.
Kind of like showing your work in math class.
Perfect analogy.
Yeah.
It's all about transparency, making sure the AI isn't just getting lucky or stumbling on the right answer.
So how did they test this? Did they, give the AI philosophy exams?
Not quite. They actually used high school math problems.
Interesting. So nothing too complex then.
Well, you'd think that, but high school math, it can get pretty hairy.
True, true.
And it requires a lot of logical thinking, applying rules, creating proofs. There's a lot of room for error if you're not careful.
So the AI could get the right answer, but you use completely the wrong logic to get there.
Exactly.
Mm.
And that's what they want to avoid. They weren't just satisfied with the AI getting a passing grade. They wanted to make sure it truly understood the material.
I like that. Holding AI to a higher standard.
Definitely. And they did this in a really clever way. They specifically trained the AI to spot solutions that were convincingly wrong.
Convincingly wrong. Okay, now you have to explain that one.
Right. So imagine a solution to a math problem. It looks right. All the steps seem to make sense. Maybe it even uses some fancy formulas.
Oh, pretty convincing to me.
Right. But then you dig a little deeper and realize there's a fundamental flaw in the logic.
So it's like the AI is learning to be its own fact checker, its own skeptic.
Exactly. And that's exactly what they found. By focusing on these convincingly wrong solutions, the AI became much better at catching its own mistakes and avoiding those logical pitfalls.
Wow, that's impressive. It's like teaching the AI to think more critically about its own thought process.
Exactly. And the results speak for themselves. They saw a significant jump in the AI's accuracy on these complex math problems just by focusing on this convincingly wrong concept.
Okay, I'm sold. Process supervision, it's the way to go. But now I'm curious, how does the Stanford research tackle this whole thinking before speaking challenge?
Well, it's a completely different approach, that's for sure. Their paper is called Quiet Star. Language models can teach themselves to think before speaking.
Wow, that's a mouthful.
Yeah, it's a bit of a tongue twister, but it hints at something pretty amazing. Basically, instead of breaking down the AI's thought process step by step, they're encouraging it to develop its own internal thought process.
So it's like the AI is having a conversation with itself while it's trying to solve a problem.
You got it. Think of it as the AI adding its own little commentary, its own notes in the margins as it's processing information.
That's wild. But how do you even begin to train an AI to do that?
That's the beauty of it. They're not explicitly programming these internal thoughts. They're using a technique called reinforcement learning, where the AI is essentially rewarded for generating thoughts that lead to better outcomes.
So it's like the AI is saying to itself, what if I try this? No, that doesn't work. Wait a minute, what about this?
Exactly. And by experimenting and learning from its mistakes, the AI gradually gets better at generating those aha moments that lead to more effective reasoning.
So it's like teaching a kid to ride a bike. You can't just tell them how to do it. They have to figure it out on their own through trial and error.
Perfect analogy. And just like with that kid who finally figures out how to ride without training wheels, the AI gains a sense of mastery and understanding that goes beyond just following instructions.
Okay, now my mind is officially blown. We have OpenAI's super structured step-by-step approach and Stanford's more free-flowing, figure it out on your own approach.
And the crazy thing is, they both seem to work, which just goes to show how much we still don't know about the nature of intelligence, whether it's human or artificial.
Such a good point. And luckily for us, we have 2 whole research papers to unpack and try to understand these different approaches. But we'll save that deep dive for after the break. Don't go anywhere. And we are back. Okay, I'm still stuck on this whole convincingly wrong thing from that OpenAI research.
Yeah, it's a real head scratcher.
It is. Like, how do they actually train an AI to spot those kinds of solutions? It seems like you'd need an army of math geniuses working around the clock.
Well, you're not wrong to think about the scaling issue.
Right.
Initially, they did rely on human experts to label those convincingly wrong solutions and kind of show the AI what to look for.
Okay, so that makes sense, but like you said, not very scalable.
Exactly. So then they experimented with this other really cool idea, which was to use a much larger, already trained AI model to supervise smaller models.
So it's like a teacher AI that's already got it all figured out, and then it's helping the student AIs learn.
Exactly. And the cool thing is, it actually worked really well. The smaller models were able to learn from the bigger models' feedback and get much better at identifying those subtly wrong solutions.
That's amazing. It's like they're building an AI school in there.
I know, right? It's AI teaching AI.
Yeah.
The future is wild.
It really is. Okay, but now I'm dying to get back to the Stanford research. This whole internal monologue thing is just blowing my mind.
Yeah, that one's a bit of a paradigm shift.
It really is. Like, we're talking about AI generating its own thoughts. It's like we're on the verge of something truly groundbreaking here.
It's definitely a glimpse into a different way of thinking about AI.
So these thoughts that the AI is generating, are they actually meaningful, or are they just random bits of code that we're interpreting as thoughts?
That's the million-dollar question, right? But the research suggests they are indeed meaningful. The AI isn't just spitting out random stuff, it's generating these internal prompts and questions that actually guide its reasoning process.
Okay, so give me an example. What would one of these internal prompts sound like?
Well, imagine the AI is reading a piece of text,
Yeah.
right? And it comes across a fact or a statement. The internal thought might be something like, this seems important, I should remember this. Or, this contradicts what I thought earlier, I need to figure out which one is right.
Wow, that's incredible. It's like the AI is having a mini debate with itself.
Exactly. And these internal debates, these little thought bubbles, there would allow the AI to stay on track, to catch errors, and to ultimately reason more effectively.
Okay, so this is blowing my mind, but how does the AI even learn to generate these useful internal thoughts in the first place?
Right, that's where the magic of reinforcement learning comes in. Basically, they reward the AI for generating thoughts that lead to better outcomes.
So it's like, good AI, you had a helpful thought. Here's a cookie.
Pretty much. And over time, the AI learns to associate those helpful thoughts with positive reinforcement, and it gets better and better at generating them.
Okay, that makes sense. But here's what I really don't understand. The paper mentions that this internal monologue approach actually helped the AI perform better on completely new tasks it had never seen before.
You're catching on quickly. That's the really exciting part. It's called zero-shot learning.
Zero-shot learning. Okay, break that down for me.
It means that the AI is able to take what it's learned in one context and apply it to a completely different context without being specifically trained on that new task.
So it's not just learning to solve, like, math problems. It's learning how to think in a way that's transferable to all sorts of problems.
Bingo. And that's a big deal because it suggests that this internal monologue approach is helping the AI develop a more general form of intelligence, something that's closer to how we humans learn and adapt to new situations.
Okay, now my mind is officially double blown.
Mine too.
It's like we're not just building smarter AI. We're building AI that can learn how to learn, which is both incredibly cool and a little bit terrifying.
Right. I mean, we're talking about AI that can potentially think for itself. And that raises a whole host of ethical questions.
Exactly. Like, what are the implications of all this? Where do we draw the line? Thankfully, that's what we're going to be digging into after the break, so don't go anywhere. Okay, so we're back, and my brain is still buzzing from all this talk about AI developing its own thoughts.
It's definitely some next level stuff.
It is, but I think it's time we brought this back down to earth a bit.
Ground ourselves, you mean?
Exactly. Like, why should all this AI reasoning stuff actually matter to the person listening to this right now?
That's the key question, isn't it? And I think it boils down to this. It's not just about making AI smarter. It's about making it more trustworthy.
Okay, I like where you're going with this. Trustworthy AI. That's something we can all get behind.
Right. I mean, think about it. If we're going to let AI into more aspects of our lives,
Right.
healthcare, finance, education,
Even just recommending what we should watch next on our favorite streaming platform.
exactly. We need to be able to trust that it's making good decisions. And more importantly, we need to understand why it's making those decisions.
So it's not enough to just have AI that works. We need AI that we can understand.
Precisely. And that's where this whole thinking before speaking idea comes in. If we can get AI to explain its reasoning, to show its work, so to speak.
It's like having that friend who always gives really good advice. And you're like, how do you always know the right thing to say? And they're like, well, here's how I figured it out.
I love that analogy, and it's so true. If we can understand the AI's reasoning process, we can start to trust it more. We can see if it's biased
Yeah.
or if it's relying on faulty data.
It's like having that window into the AI's thought process, making sure it's not going off the
Oh,
rails.
exactly. And that's incredibly important, especially as AI starts making more and more decisions for us.
Okay, so we've established that trustworthy AI is a good thing. But I have to admit, I'm still a little hung up on the Stanford research. This whole internal monologue idea, it's just so out there.
It is pretty wild, right?
It is. Like, we're talking about AI that can potentially think for itself. Are we really ready for that?
It's a valid question, and to be honest, we don't have all the answers yet. But I think that's what makes this research so exciting. We're venturing into uncharted territory here.
We really are. And who knows what we'll find. But in a way, isn't that what we humans have been doing for centuries? Exploring, experimenting, pushing the boundaries of what we know.
Absolutely. And that's what makes this whole field of AI so fascinating. We're not just building machines. We're trying to understand the very nature of intelligence itself.
And maybe, just maybe, in the process of building smarter AI, we'll learn something new about ourselves along the way.
Now you're talking. That's the real dream, isn't it?
It really is. But alas, all good deep dives must come to an end.
Time flies when you're exploring the future of AI.
It really does. But before we go, I just want to say a huge thank you to our listeners for joining us on this incredible journey.
We hope you enjoyed it.
And if you're as fascinated by this stuff as we are, be sure to check out the show notes for links to the research papers we discussed. And until next time, keep those minds curious and those questions coming.